Hey, Danny.
Hey, Professor.
How's it going?
Doing better than last week.
Okay, that's good. That's good.
Yeah. I think I was just freaking out because a lot of deadlines were last week.
Mm,
Yeah,
yeah, that's always stressful, but glad you're doing better.
thanks. Or you're doing well too, right? Hopefully.
Yeah, yeah, pretty well. Busy, but otherwise good.
Oh, Professor, once you're done with that, can I ask you a fluids question? I just need to share
Sure.
my screen real quick to show you.
Oh, okay. Um, yeah, you can go ahead. Let me stop this.
Okay. Yeah, sorry about that.
Hmm.
Oh, I think I have to be allowed to.
Oh, yes. All right, go for it.
Okay, I'm sharing my screen.
Yep. Hmm.
So this is for my other class, the fluids, the pipe design class, but
Okay.
this is based on fluids. I'm pretty sure
Hmm.
just using Bernoulli.
Hmm.
So setting up the Bernoulli, we're doing from this point to the outlet part right here.
Hmm. Yep.
The one part was that setting up the P's, because the inside right here, I think the professor kind of confused me. He said inside is pressured rise because it's not opened. It looks
Right.
like the container is closed. So therefore it's not really atmospheric, so it's not zero, I
Right.
believe.
Hmm. Yep.
But he said something about if the inlet pressure was a gauge pressure, something P2 would be zero or something, like atmospheric pressure. I was a little confused. Not sure if you can help me on that.
Yeah, yeah. So gauge pressure is the one that we use mostly in 333. And so all gauge pressure is just pressure minus atmospheric pressure. Um, and
Oh,
so
okay.
and so for this problem, he's using just regular pressure because the P2 that you see there, that's atmospheric pressure. And so this is, I guess the term more used for it is absolute pressure. Because the atmosphere, because we have air and stuff around us, that's always exerting some pressure on us, and
Right.
P2 there, that's the pressure that's atmospheric. And so if you think about this in terms of gauge pressure, then P1 would just be the difference between 175,000 minus 101,300. And so it'd be about, what is that, like 74,000. I don't
Oh,
even know what the
okay.
units are.
So if this one was gauge pressure, we just find the difference between these two, and that's the new P2, right?
No, so P2 right now is absolute pressure. And so if you're using gauge pressure, then P2 would be zero, right?
Ah, okay.
Because P2 is connected to the atmosphere. P1 is going to be higher than that because this tank is pressurized.
Right. Okay. Since it's not labeled as gauge pressure, therefore it's just atmospheric pressure.
Yeah, yeah, yeah.
Okay. Yeah. Thank you for
I
that.
mean, and what you call it doesn't really matter all too much because for Bernoulli's and for pipe flow problems, you're always looking at differences in pressure, and so
Right.
whether it's gauge pressure or absolute pressure, it doesn't really matter because at the end of the day, you're going to take just differences in pressure to find the fluid flow.
Right. Thank you so much for that.
Yep. Mm-hmm. It is, yes. Yep. That's exactly what 442 is. I don't know when I'm going to teach it next. It depends on what the department sets, but yeah, it was a lot of fun last spring. So I'm hoping to get a chance to teach it again soon. Mhm.
is it purely a spring course, or is it really just up to the department?
It's up to the department. And so the spring was the first time that I offered it. It's called a special class. And so I think for the special classes, we offer them, and I mean, they're proposed by faculty, and then, the department offers them. And I think they have to go back and look and see how it did in terms of, how many students enrolled, what the feedback from the students was. And then, they go from there. But they also have to balance that, a lot of faculty offer special courses, and there's just a lot of courses in our catalog. And so I think they try to balance it with, like, they don't want to leave any one class on the shelf for too long. And so we have a lot more technical electives and graduate courses than we can offer consistently, especially with kind of our limited amount of staff that we have. And so yeah, I don't know if they're going to offer it in the spring or if they're going to offer other electives instead. Yeah.
All right.
Yeah, so you guys aren't required to be, you aren't required to be on Zoom. And so I'm not really into the whole like spying on you guys while you guys are taking the exam. I think that's more invasion of privacy than it's worth. And so you can just take it on Canvas. But I will be here on Zoom. And so if you have questions, you can come onto the Zoom call and ask me questions. Yeah.
Could we just stay on the call, or is that okay? All right.
Yeah, no, that's perfectly fine. I mean, I'll be here the whole time. And so if you want to be here the whole time, and just so that you can have access to me right away, then that's good. Okay. Yeah, so if you don't want to use Zoom, you can message me on Discord, or you can email me. And so this is probably one of the few cases where I'll let you message me on Discord directly. Just because it's an exam, I want to make sure I get to your questions right away. And so that option's there. But I'll be having everything open. I'll be having Zoom, email, and Discord open. So you can ask on whatever avenue that you want, and I'll answer. Okay. No, today we're going to continue, and so we're going to continue with the rate of return. So the review I posted last Friday, and so that's on YouTube already. Yep. All right, it's 1 o'clock, so let's go ahead and get started today. All right, good afternoon, everyone. How's everyone doing today?
Not too bad.
Good, good. I see a lot of thumbs up. Good, good. All right, and so on Friday, so I posted the review video, so hopefully that was helpful to you all, right? And so I think if I remember correctly, the most requested topic on there was non-standard cash conversions, and so I made sure to do a couple examples of that and kind of just walk through my thought process when I'm going through those things. Okay, and so if you haven't checked out that video yet and you're studying for the midterm, then I would I would recommend that you do. It's definitely a good resource. Okay, and I posted the solutions to homework 3 just this morning too, and so I know you all just turned in homework 3 on Monday, but since the exam is coming up on Wednesday or on Thursday, sorry. I want to make sure I get the solutions to you so that you can use that to help you study as well. Okay, and so those solutions are up on Canvas. And so if you look up on the solutions in the solutions tab in the files, you can find those there. Okay. All right, and so the plan for today is we're going to continue on with our lecture notes. And so we just had a little bit more of a rate of return analysis that we need to do. Just a couple examples really. and then we're going to moving on to our next set of lecture notes, which is I call like all the other analysis types. And so you know, the other analysis types, they're kind of like the miscellaneous methods that you know, I would say are not as common or not as useful as the three that we've gone over. But you know, they do have their niche uses. And so, you know, it's kind of like the in-between topic, because after the midterm and starting next week, you know, the class is going to shift a little bit. Okay. You know, we're going to be talking more about things like taxes, like inflation, and replacement decisions. And so these are a little bit more advanced topics in engineering economics. And so this unit on economic analysis techniques is going to close out very soon. Yeah. All right. Yes. So nothing from today's lecture will be on the exam. Correct. And so the last thing that's going to be on the exam is annual cash flow analysis. And so I believe we finished that up we finished up the last of it last Thursday. And so, you know, all of the rate of return stuff is not going to be on the midterm. And so, you know, definitely check out the study guide, check out the review video, because I think those should tell you, you know, what you should prepare for on the exam. Yeah. And it'll tell you what's not on the exam too. Okay. I think that's all the announcements that I have. I'll wait to post the next homework until next week, just because I know you all are studying for the midterm right now, and so, you know, I want you guys to just focus on that, and then, you know, we'll start the next homework next week. Yeah. Okay. All right. Any other questions before we get started?
Professor.
Yep.
I have a quick question based on the final review you had.
Yep.
When converting gradients back to I think annuity, I think we do it for like 4 periods, I believe.
Yep.
And then you moved an extra year back for the, I don't know how to explain it.
Yeah. That has to do with, you know, what the standard form for the gradient is. And so remember, for the gradients, those always skip year 1, right? Because gradients always represent an increase in cash flow on top of a uniform series. And so, you know, if you look at the standard form from a gradient, and so let's say that we have a gradient G, right? Okay. And so if you look at the standard form from a gradient G, so kind of look back into our lecture notes on time value of money, you'll notice that they don't start until year 2, right? And so when you're converting this G back to like a present sum, or maybe you're converting it back to a uniform series, you have to make sure you skip over one before where the increases start happening. And so a lot of times when you're looking at these cash flow diagrams, you'll start to notice when the cash flows start to increase, and you need to go 1 before that, just because that's what the standard form for the arithmetic gradient takes. Yeah.
Okay, thank you.
Yep. All right, any other questions before we get started? Okay, all right, so let's go ahead and get rolling. So I think we actually left off in the middle of an example where I think I just barely started one. Okay, because up to this point, you know, we've been discussing this this technique called rate of return analysis, right? Okay, and so the whole idea with the rate of return is that you know, we're going to take a situation with a fixed amount of cash flows, and we're going to compute the interest rate. Right, and so it's a little bit of a different approach compared to you know, compared to how we usually solve these problems, right? And so if we think about everything with present worth analysis and everything with annual cash flow, you know, I always give you the interest rate in those problems. But for rate of return, you know, the interest rate is unknown, and so you're going to determine that based on the cash flows that we get. Okay, and so we did a few examples of that last week. Okay, but you know, what we're really interested in, or one thing we're really interested in is, can we use rate of return analysis to perform comparisons? Okay. Right? Because if you think about, what we've been using present worth analysis, what we've been using annual cash flow analysis for, we've been using those techniques to make decisions on, which option we should go with, right? So whether we should go with, a certain option with a certain amount of cash flow, or another option with another set of cash flows, right? And so, so far we've only just been doing rate of return analysis for a single option. But when you start using it to do comparisons, you have to do a little bit of an extra steps, okay? And that extra steps involve doing what's called incremental analysis. Okay. And so what this means is that, you're not just going to take the rate of return of each of your options individually. What you're going to do is you're going to take the difference, okay? Okay, all right. And specifically, you're going to take the difference between the option that costs more, and so we'll call that the higher cost option, okay? And most of the time, this is going to be the option with a higher initial cost, okay? And then we're going to subtract from that the lower cost option, or the option with the lower initial cost, okay? And then what we're going to do is we're going to find the rate of return of this increment, or the difference, and then compare it to the MARR, which is, remember, is the minimum attractive rate of return. And MARR is simply just a, you can think of it as like a threshold interest rate, okay? And so it's going to be another interest rate. And so depending on whether our rate of return is greater than the MARR or less than the MARR, that's what's going to drive our decision, okay? And so if our rate of return if our rate of return is greater than the MARR, then what this tells us is that we should go with the higher cost option. Okay. But if our rate of return is less than the MARR, okay, what this tells us is that we should go with the lower cost option. Okay. Okay. And the reasons behind this will be clear, I think once we do an example. But for now, I just want to jog your memory from last week, just so that things start to make sense in the example. But from the example, it'll kind of give some reasons behind why we have these criteria and what everything means. But I at least want to just jog your memory for what all the different terms mean and what we're looking for, just because I know you all are busy during this time with studying for, of course, the midterm for this class, but probably midterms for other classes too and projects. And so always good to have a reminder in these circumstances. Okay. All right. Any questions on this before we jump into the example again? Okay. All right. So let's go ahead and continue where we left off in the example. Okay. right? And so in this example, we have two alternatives that we're considering. Okay. And so, I would say that, this example here is very much contrived. And so, it'd be very difficult to get these rate of returns in reality. But it's mostly just to kind of, prove, just to kind of teach a point. Okay. Because I don't know what things that you can, or know where you can get this kind of return on your investment. Okay. All right. So both of these are going to be a 1-year investment. Okay. And so basically you're going to put in money in the present day, and then 1 year later, you're going to withdraw a certain amount of money. Okay. All right. And so alternative 1, so I'll call that alt 1. We're going to put in $1,000 at the beginning. Okay. And so we have you can think of this as having an initial cost of $1,000. Okay. Then you're going to deposit that money into a magic lamp, and you're going to go, wishy poo poo. And then, a year later, you're going to end up with $1,500. Okay. All right. And so in alternative 2, you're going to put in, we'll call this magic genie lamp number 2. Okay. Magic genie lamp number 2 takes $2,000. And then a year later, you're going to withdraw $2,800. Okay. Right. So maybe the magic words for this one are wishy PP or something like that. Okay. All right. And so in addition to that, we're going to take the difference between these two. Okay. And so we're going to take the difference between the higher cost option and the lower cost one. Okay. And so the higher cost option in this case is alternative 2, right? Because that one costs more upfront. That one costs $2,000. Okay. And we're going to subtract alternative 1. Okay. And so we're going to do this basically across all the rows. And so we do that across the first row. We get minus 2,000 minus a negative 1,000. And so the difference between that is going to be a minus 1,000. Okay. And then we take a difference between the benefits at the end. So we do 2,800 minus 1,500. And so this is going to be a positive 1,300. Okay. All right. And so for this problem, let's assume that we have an MARR of 10%. Okay. And so what we want to do is we want to use incremental rate of return analysis to determine which option we should go with. Okay. All right, and so let's go ahead and compute what our interest rate is for both of these cases. Okay, and so I'm going to do both of them individually. Okay, and then we're going to do the increment, and then we're going to discuss the results. Okay. All right, so let's find the individual ones first. Okay, so normally you don't have to do this, and so if I ask you to do incremental rate of return analysis, you don't have to do them individually, just because it's kind of a wasted amount of time. But I want to do it for this case just to kind of illustrate to you, why we do things this way. Okay. All right. And so let's find the rate of return for alternative 1. Okay. Right. And so remember, the way that we do this is we basically convert all the cash flows into a single form, and then we use that to find the interest rate. Okay. All right. And so for this one, since we just have single cash flows here, I think the most convenient thing to use is present worth. Okay. And so we're going to say that present worth P, okay, is equal to, we have a minus 1,000, okay, at first. because that's our initial cost for option 1. Okay. Then we're going to add 1,500. Okay. But since this occurs a year later, we have the conversion factor P over F, I, which is the unknown rate of return, and then 1. Okay. And all of this is set equal to 0. Okay. All right. And so normally at this location, you would start plugging in numbers for this conversion factor. But since this situation is so easy and we only just have 1 year, it's actually a little bit more convenient to solve this with formulas. Okay. And so for this one, we're going to plug in the P over F formula. Right. And so the P over F formula is going to be 1 divided by 1 plus I. Okay. And so this right here is the P over F formula. Okay. Right, and so that's just our compound interest formula that we went over from before. Okay, and so if we plug that formula in, then what we get is we get 0 is equal to minus 1,000 plus 1,500 divided by 1 plus I. What I'm going to do from here is I'm going to multiply both sides by 1 plus I. Okay. And so that gives us 0 is equal to minus 1,000 times 1 plus I plus 1,500. Okay. Right. And so if we perform the arithmetic here, then we get 0. And so I'm going to just distribute that negative 1,000 through, and then that's going to add to our 1,500. And so you have 500 minus 1,000 I. Okay. Right. And so if we add 1,000 I to both sides, divide by 1,000, then what we get is I is equal to 0.5, which is a rate of return of 50%. Okay. And so intuitively that makes sense, right? And so we put in $1,000, and then by the time we withdraw it a year later, then it has grown to 1,500. And so basically our money has been multiplied by a factor of 50%. Okay. All right, and so that's the rate of return of option 1 individually. Okay, any questions on this?
Professor.
Yep.
Instead of using the compound tables, why did you say to use the equation this time?
Yeah, because this time it was only 1 year, and so usually the thing that complicates using the formulas is that we have some kind of exponent here, right? And so if that n is something like 3 or 4, or sometimes it could be like 10 or 12, then solving this with the formulas is usually a bit too hard if you're not plotting it or something, right? But in this case, since our n is just 1, then it's actually just a little bit faster to use the formulas in this case.
Oh, okay. Thank you.
Yeah. It's all just about what's most convenient. It seems like the 1 plus I is missing parentheses multiplying both sides. Oh yeah. Good point. Yeah, it should definitely be like that because it's distributing throughout the entire thing. Yeah. All right. Any other questions on this one? Okay. All right. So let's do the same thing for option 2. Okay. Okay. And so for option 2, we're going to set up the present worth formula just like before. Okay. And so for option 2, we have a minus 2,000 initial cost, okay, plus 2,800. And then I'm just going to plug in the formula right away. Okay, so this is going to be 1 plus I. It's going to equal to 0. Okay. All right, and so I'm just going to run through it's basically the exact same math as before. And so we're going to multiply both sides by 1 plus I, solve for I, and then what we get is I for this case is 0.4. which is equal to 40%. Okay. And so that's the rate of return for option 2. And so for option 2, we put in $2,000, and then it grows by 40% a year later. Okay. All right, and so when you look at these two results, and so you see that for option 1, we have a rate of return of 50%, and then for option 2, we have a rate of return of 40%. You know, it seems like option 1 is better, right? Because we get more, you know, we have a higher rate of return. Okay. But you know, but we're not done with the problem yet. And so let's do the rate of return of the increment, or the difference between them. Okay. And then let's use that to decide what we're going to do. Okay? All right, and so for the increment rate of return, we have an initial cost. And so if we go back to our table, right? And so you can see our initial cost for the increment is $1,000. And then our return on the increment is 1,500 or 1,300, sorry. Okay. And so we have a minus 1,000 plus 1,300. Okay. And again, I'm just going to plug in the formula, but remember this formula represents P over F, comma I at n is equal to 1. Okay. And then we're going to set this equal to 0. Okay. All right, we're going to follow the same procedure as before. And then what we get is an interest rate of 0.3, which is 30%. Okay. Right, and so this, this 30% is the rate of return of the increment. Okay. And if you remember from the very first slide we went over today, what we need to do then is we need to compare this rate of return of the increment, compare that against the MARR. Okay. And so remember, our MARR for this problem is 10%. Okay. And so we can see very clearly that since the incremental rate of return of 30%, since that is greater than 10%, then what we should do in this one is go with the higher cost option. Okay. And the higher cost option in this case is option 2. I guess we've been calling them alternatives, so we'll call them alt 2. Okay. All right, and so that's the answer to this problem. Okay. So this might seem, you know, really unintuitive, right? And so, you know, we literally just got done computing the rate of returns for each individually, and we saw that if we do option 1, then we get a higher rate of return. And so why is it that we that all of a sudden now that we're saying that option 2 is the better one? Okay. And so the reason we're choosing you know, alternative 2 here is that it's a much better use of our money. Okay. And the main reason that we can see that is because of the MARR of 10%. Okay. All right, and so the way that you can interpret MARR is that this you can think of the MARR as the rate of return that you would get if you didn't choose either of these options, right? And so if you didn't choose either of these options and you chose to invest your money in the actual market, you know, not in these, you know, weird genie bottles or whatever, then you would only get a 10% return on your investment. Okay. And so by choosing option 2, we get to spend more of our money up front and get a more overall better haul for our money. Okay. And so on the next page, I'll kind of draw some diagrams that kind of illustrate that for you. But kind of think of that idea in mind, where like, if we chose option one, choosing option one is the lesser cost option, right? And so we would only spend $1,000. But just because of the fact that we are even considering option two, that tells us that we have at least $2,000 in our pocket that we're ready to invest. Okay, and so if we go with option one and we only spend 1,000 of that money on option one, the rest of that $1,000 would go to the MARR, and we would only get a 10% return on that investment. Okay. All right, but on the next page, I'll draw some graphs just to kind of illustrate that concept for you. Yeah. All right, question. So explain present worth formula again in this context that gets you 30%. Sure. Yeah, and so this present worth formula right here, this was obtained by finding the present worth of the increment. Okay, and so the increment, remember, is just the difference between the higher cost option and the lower cost option. Okay. And so you can see that we have these two options here. Option one costs $1,000 and option two costs $2,000. And so the difference between them is just minus 2,000 minus a negative 1,000. And so that's going to be a minus 1,000 there. And then the difference between the benefits is just 2,800 minus 1,500, which is 1,300. Okay. And so what I did for that one is I took the present worth of just this column right here. Okay. And so, kind of ignoring the first two options, and that's how I got this 30%. Okay. And so the way I set up the formula was the same as I did for option one, option two. It's just that instead of doing option one, option two, I did the difference between them. Yeah. Does that make a bit more sense? Okay, great. All right, any other questions on the example so far? Okay, all right, so let's dive a little bit deeper of why we're choosing option two in this case, even though it only gave us a 40% rate of return. Okay, and so the way you can think of these problems is that you have a fixed amount of money to spend. Okay. And the fixed amount of money that you have is equal to the cost of the higher cost option. Okay. Okay. And so in this case, the amount of money that we have to spend is $2,000 because that was the cost of the higher cost option. Okay. All right. And so by going with option two, we put all of our $2,000 into that option two. Okay. Okay. And so basically our $2,000, okay, all of it goes into alternative two. Okay. And then what we get out of it in the end is $2,800. Okay. All right. But if we went with option one, remember option one only cost us $1,000, right? And so if we went with option one, then this $2,000 will be split in between option one and the MARR. Okay. Okay. And so for option one, we have our $2,000, but now there's going to be split. Okay. Okay. And so by putting the first $1,000 into alternative one, we know that we're gonna get $1,500 out of this, right? Okay. But the rest of that $1,000, we're going to invest that at the MARR. And remember, the MARR here is only 10%, right? And so, increasing our $1,000 by 10% is only $1,100, right? And so the total amount of money that we get by choosing option one is $2,600, right? And so if you compare, right? And so if you compare the choices between, going with option two, where all of your money gets put into that, that magic genie bottle, then, you're going to get $2,800 from that. But if you go with option one, you have an extra $1,000 that you need to spend on something, okay? And so you spend that at the market rate, at the MARR, and you only get a 10% return on that, okay? And so in the end, overall, for your entire $2,000 investment, you earn less with alternative one, even though alternative one has individually a higher rate of return. And the reason for that is that it's not as efficient of a use of the money versus if you just put everything into alternative two. Okay. And so hopefully this kind of illustrates why we do the incremental analysis and why that will give us sometimes a different result than if we just did the rate of returns of each option individually. Okay. All right. So does this make any questions on this? Correct. Yes. So the fixed amount of money that we had was $2,000. Yeah. And so the way that you can determine what the fixed amount of money that you have is just look at whatever is the highest cost option, and that's how much money that you have. Okay. And that's fairly consistent with reality too, because if you're working for an engineering company and you're realistically considering the purchase of a certain machine or a certain pump, that means your company has actually budgeted the amount of money for that pump. And so you're not spending money that's not there, right? It seems it might seem like you're spending more money up front, but that money is going to be there just by the fact that you're even considering that, just by the fact that you're even considering it in the first place. Yeah. Mm-hmm. All right. Any other questions on this? I do have one more example to kind of illustrate this, these concepts. Okay. All right, so let's do one more example. So the last example was a little bit contrived, right? We have genies that respond to pee pee and poo poo, but we have we can apply this to some more realistic scenarios too. Okay. All right. And in fact, this example here has a situation where the product lives don't meet up either, and so we have to factor in some replacement decisions too. Okay. All right. And so in this example, let's say that you're working for an engineering company, and there are two machines that are being considered for purchase. Okay. All right, and so we'll call them machine X and machine Y. Okay. And so the cash flows for this one are a little bit more complicated than the last one. Okay. So we have our initial cost, we have our revenue, okay, we have our salvage value, right, and we have their useful life. Okay. And so these two machines are going to have a different useful life. All right, so machine X, this will be our cheaper option. And so machine X has an initial cost of $200. Okay. The revenue for machine X is going to be $95 we'll call this a month. Okay. Right, the salvage value is $50. Okay, and the useful life for machine X is 6 years. Okay. All right. And then compared to that, we have machine Y. So machine Y has an initial cost of $700. Sorry. Okay. The revenue is going to be $120 per month. The salvage value is $150 at the end of its life. Okay. And machine Y will say lasts 12 years. Okay. All right. And since we're going to be doing a comparison between these two options, we also need their difference. Okay. And so the difference, remember, we always formulate it as the higher cost option minus the lower cost option. Okay. And so in this case, the higher cost one is machine Y because the initial cost for that one is $700. Right. And so we're going to do minus 700 minus a negative 200. And so that's going to be minus $500. Okay. The difference in the revenue is 25 bucks. Okay. The difference in the salvage value is 100. Okay. And for the useful life, we just need to input the least common multiple. And so the least common multiple between these two is going to be 12 years. Okay. All right. And so just like we did with the last example, we're going to use incremental rate of return analysis to determine which machine that we should buy. Okay. Okay. Oh, we need an MARR. What is the MARR in this case? And the MARR in this case is 10%. Okay. All right. And so we're going to set this up just like we did the last time, but we have one additional complication. Okay. Since machine X here only lasts for 6 years, we're going to need to buy a replacement in year 6. Okay. And so there's an additional cost that we have, okay, for machine X, and that's going to be a replacement in year 6. Okay. And so the replacement in year 6 is going to cost us a minus $200. Okay. But, we're also going to salvage our first one, right? Because we bought a machine X in year 0. And so that's going to last us up until year 6. And so we're going to salvage that one. And so that's going to be a positive 50. Okay. All right. And then for machine Y, we don't have to buy a replacement. And so that column is just blank. Okay. And so you just call it 0, I guess, because there's going to be no replacement cost there. Okay. And so in addition to this, if we perform this arithmetic, it's going to be a minus 150. Okay. And so if we do the difference between this, so we do a 0 minus a negative 150. Okay. And so this is going to be a positive 150 in year 6. Okay. All right. And so does that make sense why we have that additional cash flow here for the increment? Which accounts for the replacement cost for machine X. So any questions on that? Okay. All right. And so just like what we did for the last problem, we're going to look at the increment column. Okay. And so actually for this problem, I'm not even going to consider the rate of returns for them individually. And so I'm just going to focus on the increment because that's what we can actually use to to determine which machine that we want to use. Okay. Okay, and so let's go ahead and do that. Okay. All right, and so I'm going to find the present worth of the increment. Just because, for me, present worth is a little bit more convenient, but you can of course use annual cash flow analysis as well. So you can find EUAW, but I just prefer present worth. Okay. All right, so the present worth of the increment. First, we have a minus 500 to represent the initial cost. Okay. Then we have a difference of $25 in revenue, right? And so this is going to be 25 times P over A, I, and 12. Okay. Right. Then we're going to add 100 for the salvage value. Okay. And so the salvage value is going to be P over F, I, and then at 12, right? Because this is just a one-time cost. Okay. And then we have to add our additional difference here in year 6, right? And so in year 6, we have to spend some money to replace machine X, but because we're not spending that money in machine Y, then that shows up as a difference, right? And so we're gonna have plus 150, okay, P over F, I. Okay, and since this replacement occurs in year 6, then we have to put n is equal to 6 in this case instead of n is equal to 12. Okay. All right. And so that's our formula. And so what we can do from here, right? Since this involves 3 different conversion factors, and our n's here are fairly large, they're not 1, then we need to solve this from the tables. Yeah. It's a positive 150 because it's a negative 150 for machine X, but for the increment, remember we do Y minus X, and so we do 0 minus a negative 150, and so that ends up being a positive 150 for the difference. Yeah. Mm-hmm. All right, and so we're going to start plugging in numbers from the compound interest tables. Okay, and so let's try I is equal to 1% first. Okay. Okay, and so we're going to go to the compound interest tables for I is equal to 1%, and then start plugging in values for these values for these conversion factors, right? And so if we plug in our formula, we have a minus 500 plus 25, okay? And then we have the P over A factor for I is equal to 1% and N is equal to 12. And so that's going to be 11.255, okay? Plus 100. 100 is going to be multiplied by the P over F factor for I is equal to 1% and 12, okay? And so this is going to be 0.887. Plus 150 times 0.942. Okay, so that's the P over F factor for I is equal to 1% and N is equal to 6. Okay, and what we get from this is 11. Okay, or something close to 11. Okay. All right, and so we end up with a positive number. And so, because this increment here takes the form of an investment, that means what we need to do is we need to guess higher interest rates because that's going to be more negative than what we have here, right? Because remember, for investments, we have a curve that looks like this, right? Right, and so on the y-axis we have present worth, on the x-axis we have I, okay? Right, and so it curves downward monotonically, just like that. Okay, and so if we want to get closer to 0, from a positive number, what we need to do is we need to guess higher interest rates. Okay? And so let's guess just the very next one. Okay, and so the very next one on the tables is I is equal to 1.5%. Okay, right, And so, this is going to change up all our conversion factors. And so all of these box numbers will be different. Okay. And so you input all those conversion factors, and what you get in the end is -6. Okay. All right. Okay, and so since we cross over 0 in this point, right? Since by going from 1% to 1.5%, we changed the sign of the present worth from 11 to -6. This tells us that our rate of return is somewhere between 1 and 1.5. Okay. And so, of course, that at this point we can use interpolation to find the exact rate of return. Okay. And so in this case, I think it'll be closer to 1.5, just because it's the -6 is closer to 0 than 11. But there's no point, because at this point we can see that if we remember that our MARR was 10%. Okay. Right. We can see that no matter where we interpolate, our rate of return is going to be much, much less than 10%. Okay. Right. And so since we have a situation where our incremental rate of return is less than 10%, then what that tells us is that we should go with the lower cost option. And in this case, our lower cost option is machine X. Okay. All right, and so the better thing to do in this case is to invest the $200 into machine X, and then take the rest of your $500 and then invest it in the market, because then you're going to get a much better return on your money. Okay. All right. Any questions on this? Okay. All right. And so that's rate of return. Oh, sure. What's up?
Can you explain what MARR means again?
Yeah. So MARR stands for minimum attractive rate of return. And so it's basically the threshold that your rate of return has to be over in order for you to go for the higher cost option. Yeah.
Professor.
Yeah. Mm-hmm.
Can you go over the little diagram on top on how you knew to increase instead of decreasing the interest?
Yeah. And so for remember we made these two plots, right? And so the plots were on the y-axis we had present worth, and on the x-axis we had interest rate, right? And so depending on if your cash flow was an investment or a loan, then this curve looks different. Okay. And so for a loan, right? For a loan, your relationship looks like something like that, right? And so it's a function that monotonically increases, right? But for an investment, remember, an investment is characterized by you pay some kind of cost up front, but then you get more benefits later. Okay. Right. An investment looks something like this, right? And so it's a function that monotonically decreases, right? And so what I did at that point was we tried out an interest rate of 1%, right? And so we found that we got a positive number, right? And so we got positive 11. Okay. And so since we're on an investment, we kind of just ignore this, right? And so that tells us that we're somewhere here, right? Where this green dot is. Okay. And so ultimately we want to find where this crosses the x-axis. And so we want to get closer to a present worth of 0. Okay. And so by the fact that we know that we're somewhere like right here, and we want to go towards a present worth of 0, that means that in order to get there, we have to guess a higher interest rate. Okay. Because we could have easily taken this result and say that we got a present worth at I is equal to 1% of 11, and so you can say that let's try let's try the present worth at I is equal to 0.5%. But then that would get you further away from 0. So that would get you, something like 20 something or something like that when we want to go towards 0.
Right. Thank you.
Yep. All right. Any other questions on rate of return or anything from this example? Okay. All right. And so that's rate of return analysis. Okay. And so the next thing that we're going to do, and this is going to close out our first big unit here. I would say the first half of our economics, which is based on economic analysis techniques. Okay. And so, so far we've done 3 different techniques. Okay. And so the 3 techniques that we've gone over are, one is present worth analysis. Okay. 2 is annual cash flow. Okay. Annual cash flow analysis. And 3, which we just finished just 5 minutes ago, was rate of return analysis. Okay. And so these, I would say, are the 3 most common that are used for performing economic analysis. Okay. But there are others out there. But with these 3, you have kind of a good tool set already. But there are some niche situations where you would use some other stuff. Okay, and so with this set of lecture notes, I just want to go over very quickly of what some of those other methods are, and when you would use them versus the other ones. Okay, and so there are three main techniques that I want to go over. Okay, so one is called benefit cost ratio. Okay, the next is called a payback period, and the last one is called break-even analysis. Okay, and so I think today, just because we don't have too much time left, I think we'll just start going over benefit cost ratio, and then after the midterm, we'll start talking about the other ones. All right. And so first, let's start with benefit cost ratio, and I would say this is probably the most useful out of the 3 that we're going to cover. Okay, but it's also very similar to what we've done. Okay, all right. And so in benefit cost ratio, what we essentially do is that when we look at an economic option, we separate it into the benefits, which remember are the positive cash flows, versus the cost. Okay. Okay. All right. And so the benefit cost ratio is then just the ratio between these 2. Okay. But the key to this is that you have to convert all of the benefits and all of the costs into the same form of cash flow. Okay. Okay. All right, and so you can either convert all of the benefits into a present worth, all the costs into a present worth. Okay, and so that's a popular one. Or you can convert it to a uniform series too, and so that would be the EUAB and the EUAC. Okay, and so the definition for benefit cost ratio. Okay. The ways this is defined is we can either take the present worth of all the benefits, okay, all over the present worth of all the costs, okay. And this is equal to, another way you can do it is you can take the EUAB, right? Remember, EUAB stands for equivalent uniform annual benefit, right? And so that's the uniform series representation of all the benefits in your economic option. Right, and then we divide it by the EUAC, which stands for the equivalent uniform annual costs. Right, and so that's the uniform series representation of all the costs in your, in your economic project. Okay, and what you're checking for in these situations is if you're going to be checking whether this ratio is greater than or equal to 1. Okay. Right. Because if this ratio is greater than 1. What that tells you is that the benefits are going to outweigh the costs, and you're going to earn more money than you put in. Okay, and so basically, a benefit cost ratio greater than 1 is deemed a desirable, or it's deemed an economically efficient option. Okay, and so nothing too new here. It's just that we're going to be doing cash flow conversions just like we usually have. It's just that afterwards you're going to be taking a ratio, of the results, which we haven't done before. Okay. All right. Any questions on how benefit cost ratio is defined? Okay. All right. And so we can use this to perform comparisons too, right? And so just like we've used present worth, just like we use just like we use rate of return, which we use incremental analysis with, and just like we've used annual cash flow, we've used these to determine, which options are economically more efficient or economically superior. Okay. Okay. But if we want to do this, very similar to rate of return analysis, we have to do it based on the increment. And so we can't do benefit cost ratio of each one individually, but we have to do them based on the increment and then make our decision based on the increment. Okay. All right, and so let's redo an example that we've done previously, but we're going to use incremental benefit cost ratio in order to solve it. Okay. All right, so I think we've done this problem, at least twice already. I think we did this present worth analysis and with annual cash flow, but let's see how it works with benefit cost ratio. Okay, and so let's say that we're working for an engineering firm, and we're deciding between the purchase of 2 different machines. Oops. Okay. And so let's list out the specs for option A. And so option A has an initial cost of $10,000. Okay. Right, and then the revenue from option A is going to be $3,000 per year. Okay. Right, and so that $3,000 is going to take place every year. Okay, machine B. Machine B has an initial cost of $13,500. Okay, the revenue from machine B is also going to be $3,000. Okay, but machine B also has a gradient. Okay, and so the revenue is going to increase per year by an amount of $500. Okay, and so if we assume an interest rate of 7%, okay, and we assume an analysis period of 5 years, okay, we're going to use in this case, we're going to use benefit cost ratio to determine which machine that we should buy. Okay. All right. And so, in order to use benefit cost ratio, remember that we have to separate what are the benefits and what are the costs in our situation. Okay. All right. And so let me label the costs first. Right. And so in this case, the costs are fairly simple, just because we only have a initial cost for both options. Okay. And so I'm going to highlight the cost in red. Okay. Right. And so both of those are costs. Okay. And then the benefits are going to be in blue. Okay. Right. And so in both cases, we have a revenue of $3,000. And so that's going to be in blue. Okay. And we also have a gradient benefit for a machine B. And so I'm going to circle that one in blue as well. Okay. All right. And so let's start by just taking computing the benefit cost ratio of each option individually. Okay. Which again, for most cases you don't have to do this, and so for most cases you just have to do the increment. But just as an illustrative example. All right, so let's do a machine A. Okay, and so for machine A, we're going to take everything, all the cash flows, and then convert it into the same form. Okay, and so I'm going to do it based on present worths. Okay. Actually, let me do this in red. Okay, because this is going to be the present worth of the costs, right? And so for the present worth of the cost, we just have a single one, and that's our initial cost. And so this is just going to be simply $10,000. Right. Meanwhile, the present worth of the benefits this is going to be $3,000. But we have to convert, because this is a uniform series, because it's a revenue that occurs that recurs every year, okay? And so we have to convert it to the present sum, and so we're going to do P over A. The interest rate is 7%, and the N is 5, okay? And so we plug in those numbers, and then what we get is 12,300. Okay. All right, and so if we take those numbers and we compute the ratio. Okay. Remember, the ratio is the present worth of the benefits over the present worth of the costs. Okay. And so we're going to take the 12,300 and divide it by 10,000, and so this gives us 1.23. Okay. All right, and so that's the benefit cost ratio for option A. Okay. All right, any questions on how we computed this? Okay. All right, and so now let's do the benefit cost ratio of option B. Okay. All right, and so just like we did for option A, we're going to find the present worth of the costs. Okay, and so present worth of the cost in this case, we just have an initial cost, right? Right, and so the present worth of the cost is going to be 13,500. Okay. And then we're going to find the present worth of the benefits. And so in this case, we have two sources of benefits. And so we have the uniform series of 3,000, and we have our gradient of 500 as well. Okay. And so we have 3,000 P over A, I is equal to 7%, and N is equal to 5. Okay. Plus 500. And this is going to be P over G, 6%, and 5. Okay. And so if we do this, then we get 16,120. Okay. And so the ratio between these the ratio is going to be the present worth of the costs divided by the present worth of the benefits. Oh, sorry, I did the reverse. Present worth of the benefits on top. Right, and on the bottom, we have the present worth of the costs. Okay, and so we compute this ratio, and what we get from this is 1.19. Okay. Oh, sorry about that. Yeah, it should be 7%. The interest rate should not have changed. Yeah, that was my mistake. All right. And so from both of these, ratios, it might seem like, again, like option A is the better one to go with, right? Because it has a bigger benefit cost ratio. Okay. But you can't just base your decision off of off the individual ratios, right? So just like we did with the rate of return analysis, we need to find the benefit cost ratio of the increment. Okay. All right, and so now we're going to compute two new present worth, and so we're going to compute the present worth of the incremental costs and the present worth of the incremental benefits. And so the incremental cost is just going to be the difference between the higher cost option, all the costs associated with the higher cost option, minus all the costs associated with the lower cost option. Okay. And so in this case, we just have two options, and they just only have an initial cost. And so the difference between them is going to be 13,500, okay, which is the initial cost for option B. Okay. And then from that, we're going to subtract 10,000, which is the initial cost for option A, right? And so the incremental cost in this case is just going to be 3,500. All right, and so next we're going to compute the present worth of the incremental benefits between the two, okay? And just like we did with the incremental costs, we're going to take all the benefits from option B, which is the higher cost option, okay? And we're going to subtract the benefits from option A, which is the lower cost one, okay? And so for option B, what we have here is a 3,000 P over A, 7%, and 5, okay, plus 500 P over G, 7%, and 5. Okay. And then from this, we're going to subtract the benefits from option A. And so option A, we just had 3,000 P over A, 7%, and 5. Okay. All right, and so you can see from this that these are going to cancel out, right? Because they're the exact same thing. Okay. And so if we plug in the conversion factor P over G for 7% and 5 into this equation, then our present worth of the incremental benefits is 3,820. Okay. All right, so now that we have the incremental benefits and the incremental costs computed, we can now compute the incremental ratio. Okay. Okay. And so the incremental ratio in this case is the present worth of the incremental benefits divided by present worth of the incremental costs. Okay. And so this is going to be 3,820 divided by 3,500. Okay. And so if we do that, we get a ratio of 1.09. Okay. Right. And so we're going to take the same attitude that we did with rate of return and at MARR, right? And so since the increment is greater than 1, okay, what this tells us is that the better economic option or the better economic alternative here is the more expensive one or the higher cost one, okay? Okay, and so the higher cost option in this case is option B, right? Because that one has a higher initial cost, okay? All right, any final questions on this example here? Okay, all right, so that's all we got time for. And so thank you everyone for tuning in. And so remember, Thursday is our midterm. And so if you want to come to the Zoom call and just be on the call and ask questions, that's fine. But it's not a requirement. And so if you would rather just take the exam in peace, without Zoom, I know there's a lot of benefits to that too, and so feel free to do that too. Okay, and so I have office hours right after class, and so if you have any questions about the midterm, feel free to drop by then. I also have office hours tomorrow from 1 to 2, and so there's that option available too. Right, and so best of luck studying for everyone. Make sure you check out the study guide and the review video and to help you study. And I will see you all on Thursday if you're there. But if you're not, I'll see you next week.
Professor?
Yeah. Mhm.
Can I ask you a quick question? I was wondering if you could turn back the page just once.
Yeah.
I didn't catch everything.
Sure.
Thank you.
Yeah, and there's a question in the chat for how long do we have for the exam, and so it's going to take place just during the lecture period. But I'm going to give you an extra 15 minutes, and so it's going to be a 90-minute exam. And so it's going to start at 1 p.m. and it's going to end at 2:30. Yeah.
Okay.
Professor,
Thank you,
first
Professor.
question.
Sure. What's up?
So I turned in my homework 3,
Yeah.
but it was incomplete. So I
Uh-huh.
was just gonna, but I turned it in on time. It was just wasn't complete. So I was gonna turn it in again, but complete.
Yeah.
So I was wondering if it was still worth to do that. I didn't even know the solutions were up. I was just gonna try again.
Yeah. So I mean, the late policy I have in this class is that I accept late homeworks up to a week after the due date. And so what I can do is that I can grade what you have right now, the one that you turned in on time. I'll grade those for full credit. But my late policy is that for every day that that the homework's turned in late, then I take off 10%. And so I can take off 10% off, whatever you finish or you turn in at any given time for your whenever you turn it in. Okay.
Okay, thanks.
Yeah. Mm-hmm.
Professor,
Yeah.
I have a question. So for the exam, it's not mandatory to be on Zoom, right?
Correct. Yeah.
Okay. And so we also we'll turn it in through Canvas? Or-
Yes. Yeah.
Okay.
It's all given through Canvas.
Okay. And it's open notes, right?
Yes, correct. It's open notes. The only thing I ask that you just please don't communicate with other other people in the class, and please don't post the problems on Reddit or Chegg or anything like that. And so I need these exams. So these exams I need I need them as a form of assessment for each student individually. And so once if you ask outside help or anything like that, then that defeats the purpose, and and it counts as academic dishonesty. And so I'll be checking Chegg, I'll be checking everything just to make sure nothing's posted there. So
Right.
so yeah.
And Professor,
Yeah.
is it okay if I do the exam on my iPad?
Sure.
Or-
Yeah.
Okay.
That's fine.
Okay. Sounds good.
Yep.
All right. Thanks.
Right. Christopher, did you have any more questions? Okay. All right. So I'm going to end the call. If you have any more questions, then you can come to office hours.